Hi, students. We are going to start chapter 11. A lot of chapter 11 is going to deal with solving quadratic equations and some extensions that come from that. This lecture is going to be on section 11.1, solving quadratic equations by completing the square. There's a multitude ways to solve quadratic equations. We're going to learn each of them. It's important to know how to do all of them so that you can choose the appropriate method to make it easiest on yourself, depending on the equation that presents you. So let's just define a quadratic equation. So a quadratic equation is a second degree equation, and it can be written in the form ax squared plus bx plus c equals 0. This is where a, b, and c are just real numbers. The one condition is that a cannot equal 0. If a equals 0, then we no longer have that second degree equation. All right, and keep in mind this quadratic can be written in this form. That's what makes it a quadratic, but it doesn't necessarily mean it will be written in this form. Okay, so those are quadratic equations. They come up a lot. You want to get really comfortable with them. Hopefully you've already looked at the video factoring quadratic equations. That's in the very first module. I have a supplemental video on how to factor quadratic equations. You're going to want to be able to do that. So make sure you've seen that video or know how to factor quadratics. What we're going to do in 1.1 though is learn how to solve quadratics by completing the square. And to do that, we're going to use what we call the square root property. So the square root property tells us that if a squared is equal to b, then a is equal to either the positive square root of b or the negative square root of b. Okay, that means that a can be both the positive square root of b and the negative square root of b, and both of those situations will make this equation true. Okay. What that really allows us to do is when we get into this situation where something squared equals something else, we kind of take the square root of both sides, but don't forget to add in the possibility for it to be a plus or minus, because this squaring makes whatever a is automatically positive. Okay. So that's the square root property. We also use the zero factor property when solving quadratic equations. The zero factor property tells us that a product of factors equals 0 if and only if one or more of those factors is 0. So what that means is that if a times b equals 0, then either a or b have to equal 0. And it's possible that both a and b equals 0. Here are some examples that I want to do for you to show you how we would solve these quadratic equations using the square root property. Okay. So let's take it to the whiteboard and I'll go through each of these 4 examples and show you how we're going to solve them. All 4 of these different equations are all quadratic equations. Notice they are second degree equations, but it's true that none of them really look like this form we have up here for our quadratic, but we can, if we wanted to, write them all in this form. Okay. As we get further in this section, you're going to notice that these are all in a certain form that actually allows us to use the square root property to solve them fairly directly. Later on, we're going to get some different quadratics. Oftentimes, if quadratics are written in this, what we call standard form, then the square root property isn't always the best approach. Then we're going to use maybe the zero factor property or the quadratic formula. But these 4 are very nicely formatted for us to use the square root property. So let's go to our whiteboard and I will show you how we're going to do that. All right, so here's our first example, x squared equals 9. We're going to use the square root property to very easily solve this equation for x. So since x squared equals 9, that means that x equals the square root of 9, x equals plus or minus the square root of 9. And essentially, you can think about it as we're taking the square root of both sides, okay? So then we get x on the left-hand side, and we have to remember that because x squared is 9, x is really going to equal plus or minus the square root of 9, which is 3, right? So we have two solutions here. If x squared equals 9, x can equal 3, or x can equal -3. Let's take a look at our next example. The 2x squared minus 14 equals 0. Right. So at first glance, we can't go straight into using the square root property because we don't have something squared equaling something else. But we can do a little bit of rearrangement. We can add 14 to both sides. So we get 2x squared equals 14. And then we can even divide by 2 on both sides so that we get x squared equals 7. All right, now that we've got x squared equals 7, we can again use that square root property, and we get that x is equal to plus or minus the square root of 7. Okay. So here again, when you look back at our original equation, if x equals 7, we've got, or sorry, if x equals the square root of 7, square root of 7 squared is 7, 7 times 2 is 14, 14 minus 14 is 0. So x can be the square root of 7, but x can also be negative square root of 7, because when we square the negative square root of 7, it also becomes a positive 7 times 2 is 14, minus 14 is 0. Okay, so that gives us two options there. Let's take a look at example 3. Example 3 is x plus 1 squared equals 12. And if you have done some solving of quadratic equations, it might be your instinct to multiply out this squared binomial. But really, we're in a state where we have something squared equals something else. So this is a perfect candidate for our square root property, where we take the square root of both sides. But remember, if we take the square root of a perfect square, we have to include that plus or minus. So what we are now going to say x plus 1 equals plus or minus the square root of 12. Okay. But now we want to solve for x, so we need to subtract 1 from both sides. And what that's going to look like is x equals -1 plus or minus the square root of 12. Okay. This is two different answers because one is a plus, one is a minus, and we also need to simplify this square root of 12. So let's just take a little aside and simplify that square root of 12. So square root of 12, since 12 is 3 times 4, we can rewrite that as the square root of 3 times the square root of 4, or if you prefer, you could rewrite it as the square root of 3 times the square root of 2 squared. Either way, we know that the square root of 4 is 2, or the square root of 2 squared is 2. So that square root of 12 ends up looking like 2 root 3. Okay, so we're going to replace our square root of 12 with a square root of 2 root 3. And so our answer becomes x equals -1 plus or minus 2 root 3. And that is two separate answers. So those two answers are -1 plus 2 root 3 and -1 minus 2 root 3. So those are the two possible values that x can take on to make our original equation true. And let's do one last example. X minus 2 squared equals -4. All right. This at first glance appears very similar to the last example. We're going to use that square root property, square root both sides, and in doing so, not forget our plus and minus. That gives us that x minus 2 equals plus or minus the square root of -4. And we, of course, are going to add 2 to both sides to completely solve for x. So we've got that x equals 2 plus or minus the square root of -4. But what are we going to do with the square root of -4? Let's take a little aside. We've got the square root of -4. That's an imaginary number because we have that negative sign there, okay? So we are going to factor out the -1. So we've got the square root of 4, and we've also got the square root of -1. And then we can rewrite that square root of -4, or square root of 4 is just 2. And the square root of -1, we like to write as an I. So our square root of -4 is going to become a 2i. So our answer is that x equals 2 plus or minus 2i. Now this is a complex number because it contains that imaginary part. It is not a real number. It's a complex number, which means that it cannot be graphed on the real number line. Okay. All right, so that's example number 4. Let's move on. If you need to take some time to go back through those examples, feel free to pause and go back, okay? So you see, I've got each of our answers written out here. Oops, that's supposed to be a 7, not a 17, just ignore. Each of our answers written out here for you guys to reference in the PowerPoint. So this completing the square allows us to use the square root property to solve actually any quadratic, not just the quadratics we saw in the form on the last slide. And to use completing the square, to use the square root property to solve any quadratic, what we would have to do is take any quadratic and get it into a nice pattern where the coefficient on our x term and our constant term are related as shown here. And then they will actually fold back into a perfect square binomial, okay? Let me show you how we can complete the square in order to use the square root property like we did in the examples on the last page. And actually first, let's take a quick look at the examples on the last page and what they looked like, especially these last two. So you see how we have a binomial squared equals a constant term in this third example. Basically, we are going to do a thing called completing the square to get our quadratic to look like this, all right? Or to look like this. So let me show you how we're going to do that from any type of quadratic that we're presented with. So here we are given a quadratic x squared plus 2x minus 4. That looks better. X squared plus 2x minus 4 equals 0. So here's a quadratic that's in standard form, and it's not really in a situation where we can take the square root. And that's because we've got an x in 2 places, right? So we've got our x squared and we've got our x somewhere else. Oftentimes with an equation like this, you may want to try to factor or try to use the quadratic formula, which I'll show you guys later. But if we want to, we can actually use this technique I'm just about to show you called completing the square. And what we're going to do is we're going to take our quadratic, which looks kind of like this, although not quite this same relationship. We're going to make it have this relationship between the coefficient on x and the constant term, and then we're going to fold it up into this perfect square so that we can use the square root property. Okay, so let's take a look at how we would do that. Here, in order to fold up into a perfect square, the coefficient on x, if we divide the coefficient on x by 2 and square it, that's what we want our constant term to look like. And if we have that relationship between the coefficient on x and our constant term, we can fold this into a perfect square binomial. So the thing that we can really change is our constant terms. We can add and subtract stuff to both sides really easily. So we are going to manipulate this constant term so that it has this relationship to the coefficient on x, so that we can fold it up into a perfect square. So notice that our coefficient on x is 2, and we want our constant term to be the coefficient on x divided by 2 squared. So we call that b. I want you guys to keep in mind this b that I'm talking about here is not the same b as in our quadratic equation formula b. I'm not talking about the coefficient on x b. This b that I'm talking about is actually half of what the coefficient on x is. Okay, not to confuse you. Okay. So what we need is for our constant term to be this coefficient divided by 2 squared. This coefficient is 2, so 2 divided by 2 is 1. So our b in this formula is actually 1. So 1 squared is 1. So our b squared is 1. That means we need our constant term to be a 1. Right now, our constant term is a -4. Okay. We need to turn this -4 into a +1 in order to get this relationship here to fold up into a perfect square binomial. It's not as hard as it sounds. Let's get that -4 out of the way by adding 4 to both sides. And now we want a 1 as a constant term, so let's just add a 1 to both sides. Now you can see that we've got the relationship we want. If 2 is a 2b, then b squared is 1. And if you try to factor this, what two numbers multiply to 1 and add to 2, they both happen to be 1, which means when we factor this guy, it's going to factor to x plus 1 times x plus 1. All right, so take a second. We're ignoring the right-hand side, and we're just factoring the quadratic we have on the left. This is a little different than how you usually would factor, because normally we would set it equal to 0 before factoring. But in this case, we've engineered our quadratic to fold up into or to factor into a perfect square. We've engineered that constant term at the expense of having some constant term over here so that it folds into this perfect square, right? So you see that when you factor these 3 terms, they factor as x plus 1 times x plus 1, which means x plus 1 squared. Right? Now we've got x plus 1 squared is equal to 5. And now we have done what is called completing the square, and we can use that square root property to solve this quadratic. All right, so we'll take the square root of both sides, and we get that x, and then we'll take the square root of both sides, we subtract 1 from both sides, and you see that x equals -1 plus or minus the square root of 5. Okay. The nice thing about this completing the square method is that you can actually use it with any quadratic you get. If you were presented this quadratic at first, you might say, well, why don't we just factor it from the beginning and use the 0 factor property? But you see, when you try to factor this, there are you can't factor this into two binomial factors. Go ahead and take a second to try. 1 times 4 equals 4, but there's no way you can get a 1 and a 4 to add up to a 2. 2 times 2 equals 4, but there's no way you can get a 2 and a 2 to add up to 2. So this won't factor into two binomial factors. The only way to solve this would be to use the quadratic formula, which we'll talk about later, or this completing the square method, okay, which always works. Okay. So that's completing the square. You might want to take a little bit of time to go back over what we just did to make sure you understand each step. Okay. I'm going to do these two examples on my whiteboard to help you guys understand how this works. All right, so we've got our 2x squared minus 8x plus 3 equals 0. All right. If we want to solve this by completing the square and using the square root property, we first have to get rid of the coefficient on our very first term. So first, we're going to divide both sides by 2. And in doing so, we end up with an x squared minus 4x plus 3/2 equals 0. Okay. Now we have to identify what we want for our constant term. So we have a -4 here. We need to take our -4, divide it by 2, and square it in order to find what we want for our constant term. So -4 divided by 2 and squared actually just ends up being a +4. So we need to put a +4 here as our constant term. So let's get this 3/2 out of the way just by subtracting both sides by 3/2. -3/2, okay. And now we know over here that if we want to fold into a perfect square, we know that the constant term we need here is got to be a +4. So we're going to add 4 to both sides. And again, we know that we need a +4 here because if we call this 2b, we know by the pattern on the last slide we saw that we need a b here. So if this is 2b and we need, a b squared, then we just take this, divide it by 2, square it, and that's the number to add here. Keep in mind, this -4 is actually just staying a -4. We're just dividing it by 2 and squaring it over on the side just to figure out what we're adding to both sides, okay? So now what we've done is we've just engineered our constant term to have a special pattern so that when we factor this, we're going to ask ourselves, okay, what two numbers multiply to 4 and add to -4? Well, it's -2 and -2. So this factors to x minus 2 times x minus 2, which can also be written as x minus 2 squared. Okay, so what we're doing here is different than your regular factoring. We're engineering this constant term so that we always factor to a perfect square. Or what I mean by that is we factor so that both our factors are identical. Okay. At the cost is that on the right-hand side, we no longer have a 0. We have those extra constant terms that we had to kind of rearrange. So 4 plus a -3/2, 4 is 8/2, and then we're going to subtract 3/2. So we're going to get a 5/2 over here. Okay. That was just me adding those two terms on the right-hand side. So now we've got x minus 2 squared equals 5/2, and we can now use our square root property. So what we just did was completing the square. We are now going to use our square root property to finish this off and solve for x. So this is going to look like x minus 2 equals plus or minus the square root of 5 over 2. All right, so we completed the square in order to use the square root property. And from the square root property, we can now solve. We're going to add 2 to both sides, and we're going to get that x equals 2 plus or minus the square root of 5 halves. And that is how you can solve that equation using the square root property. Completing the square on the square root property. We also could have solved that equation using the quadratic formula, but it is good to know how to use the square root property because we are going to need it later. Okay, let's go on to our next example. The next example is x squared plus 5x minus 3 equals 0. So here, if we want to use the square root property, we are going to, let's first of all get that -3 out of our way. So we've got x squared plus 5x equals 3. So all I did was I just added 3 to both sides. And now when we want to figure out, okay, what do we want for our constant term? We're going to take this 5 out to the side. We're going to go 5 divided by 2 and squared. That's going to be what we need for our constant term. So our constant term is going to be 25 over 4. Not a very fun constant term, but that's what we are stuck with if we want to use this method. So we're going to say plus 25 over 4 and plus 25 over 4. Okay. Now we're going to factor this stuff on the left-hand side. Make that look like, there we go, 25 over 4. We're going to factor this stuff on the left-hand side, and you might think, oh my God, like I can't factor this with these, with this fraction as our constant term. But here's the thing, we know that our b is this 5 over 2, right? Our b is half of whatever the coefficient on x is. So we actually know that this is going to factor to x plus 5 over 2 squared. And go ahead and understand how that works out. When we take an x plus 5 over 2 and we square it, we're going to get our x squared term, and then we're going to get 2 of these cross terms. So x times 5 halves plus x times 5 halves is going to give us 5 halves plus 5 halves x, which is going to give us 5x. And then we're going to get our 5 over 2 times 5 over 2, which is going to give us that 25 over 4. So sometimes just expanding this binomial multiplication will help you understand how we got to here. And that will help you understand how we went from here into this factorization. Okay. But you don't need to struggle through factoring this into here, because we know, since we've made it a perfect square, we know that the factor of this is going to be x plus half of whatever this coefficient is. Okay. Now on the right-hand side, we got to add these two things together. This is 12/4 plus 25/4. So that is 37 over 4, okay, as our constant term. Now we take the square root of both sides now that we have completed the square. And remember, anytime you take the square root of a perfect square, get that plus or minus on the other side. So now we have x plus 5 halves equals plus or minus the square root of 37 over 4. And keep in mind, we can use the quotient rule. And if we want to, we can actually take the square root of that denominator right away. So we've got the square root of 37 over the square root of 4. But the square root of 4 is just 2. Okay, so we can rewrite it like that early on if we want. Now, all we have to do is subtract that 5/2 from both sides. And I'm just going to do it on the same page here. So we're subtracting 5/2. And we get that x is -5/2 plus or minus 37/2. Another way to write that, let me see if I can write it on the same page for you guys. So x is going to equal -5 plus or minus the square root of 37 all over 2. So it looks a little messy, but these are our two answers. So one possible value of x is -5 plus the square root of 37, all divided by 2. The other possible value of x is -5 minus the square root of 37 plus 2. All right. So that is how completing the square works. Later on, we're going to discuss when you should use completing the square and the square root property, and when you should use factoring or the quadratic property instead. Take your time, look over those videos, and I'll come back with a video for 11.2 next.